I want to say one final thing about Hilbert's eighth problem. Hilbert's eighth problem, again, was actually a set of three problems, all to do with prime numbers. The Riemann hypothesis, which is about the zeros of the Riemann zeta function, and if we could prove that all of these zeros lie on a particular line, then we'd be able to prove a lot of things about prime numbers. The Goldbach conjecture that every even number greater than 2 is the sum of two primes, and the twin prime conjecture that there is an infinite number of pairs of primes such that they're separated by a single other number, primes like 11 and 13. Now, what I want to say is this. You might have noticed from some of the previous problems, for example, the continuum hypothesis, that Hilbert put out there, that we weren't able to prove or disprove them, but we were able to prove that we couldn't prove them. And the continuum hypothesis, again, is that there is no intermediate infinity between the size of the set of counting numbers and the size of the set of real numbers. There's nothing between those. And we just managed to show that this is an undecidable problem according to the axioms that we have of mathematics, the Zermelo-Fraenkel axioms of set theory. Could it be the case for these three problems, the Goldbach conjecture, the Riemann hypothesis, that they're in the same bucket, that they're just not provable either way? Well, it's not clear. We don't know. One thing that we do know is that if the Riemann hypothesis or the Goldbach conjecture is false, then it would be provably false, because all you'd have to do is show one counterexample. So one example where you have an even number that is greater than 2 that is not the sum of two primes. Likewise, you could do the same with the Riemann hypothesis. So if you feed a number into the Riemann zeta function, which is has a real part which is greater than 0 and less than 1, but it's not a half, you've disproved the Riemann hypothesis and you've won $1 million. So if they're false, then they're provably false. But if they're true, well, we don't know if there's a way of proving that using the axioms yet. There might be, there might not. You could just say, well, maybe we can just brute force it. We could just check every single even number. And that's a lot of numbers. In fact, it's an infinite number of numbers, but it is a countably infinite number of numbers. So it's the sort of minimum infinity. And that's one of the arguments that gets used to suggest that these are probably provable, but we don't know. So this could be a huge wild goose chase.